Salam alaikum. Good morning, good afternoon, good evening from wherever you are watching this video. So, in our previous lecture, we discussed about reflection of light at curved mirrors. So, today we are going to look at reflection terms used in curved mirrors and uh, which include concave and convex mirrors. So these terms that are used in reflection, these are what we are going to discuss in this lecture. The term used in reflection at curved mirrors, at concave and convex mirrors. So as we are going to discuss these terms, so let us start with the fall. What is fall of a curved mirror? So we say a pole of a curved mirror is a geometric center of reflecting surface. Pole is a geometrical geometric center of reflecting surface. So let's try to draw here and see what does the pole of the mirror mean. So if this one is our mirror, if this one is the mirror, let's say concave mirror. So what is the pole of this concave mirror? So a pole of a concave mirror here is a geometrical center. So it is just meaning a center of aperture. It is a center of aperture of a mirror. So a reflecting surface is this. So this center of reflecting surface of a mirror is what we call pole of the mirror. It is the same for both concave and convex. So this midpoint is what we call pole of the mirror. Pole of the mirror. So it is known as what? Known as geometric center of reflecting surface. Geometrical center of reflecting surface. So that is what we refer to as pole of the mirror. So let's come to center of curvature. What is meant by center of curvature? Center of curvature of a curved mirror. Center of curvature of a curved mirror is the center of a sphere which a mirror forms a part. It is the center of a sphere of which the mirror forms a part. So let's say this is our sphere. So when you dot this one here, this center of sphere, like the center of the circle, this center is what we call center of curvature. Here, this part in the middle. So if we cut this one here into two, this sphere into two here, so this part will remain. So assuming this section is going to form the mirror, this section is going to form the mirror here. So this point is what we call center of curvature. Center of curvature. It is center of a sphere which the mirror form is a part. Center of a sphere of which the mirror form is a part. So if we remove all this drawing and then we only cut the part, the mirror, we only cut the mirror here. Let's say this is our mirror. So this is our mirror. So how do we locate the center of curvature? So a center of curvature of this mirror is here. Let's say this is this line. So we have already understood where we locate pole. Pole is this point. This point, the half of the aperture, the surface. Aperture means surface of the mirror here. So this midpoint is what we call fold. We already learned it before. So the center of curvature here will be at this point here. So if we are to complete this, it will form a sphere. So it will form a sphere, which means this is going to be the center. So we refer to this one as center of curvature. Center of curvature. Okay, let us come to principal axis. What is meant by principal axis? Principal axis of a curved mirror is a line passing through the pole. It is a line passing through pole P and the center of curvature. So let us see how it looks like. Okay, here is our sphere. Let's say this is going to be the mirror. Let's say this side, this is the part that we cut to be our mirror. Let's say this is our mirror here. So the center of this mirror is here, which is referred to the center of the mirror. The center of a mirror here is going to be this part, which is referred to as fold. So, and we say here the middle part, this point here in the middle, this one is known as what? Center of curvature. We already learned it before. So, and this one is the pole. So we are saying principal axis is a line passing through fold. It is a line passing through fold. Here is our fold. A line passing through fold, pole, and the center of curvature. So you combine the two. So this line is what we refer to as principal axis. So principal axis is a line passing through the fold of the mirror and the center of curvature. So this line here is what we refer to as principal axis. Principal axis. Okay, let's come to radius of curvature. Radius of curvature, which is represented by R. So radius of curvature of a curved mirror is the radius of a sphere of which a mirror forms a part. It is a radius of the sphere of which a mirror forms a part. So if we draw this one to be a sphere, radius of curvature, which is represented by R, so it is the radius of a sphere. So this is the sphere. So when you divide this one into two, so this is the center. We said before that this one is center of curvature. So what we call radius of curvature is this, assuming this one is the mirror. This part here is the mirror section. This section here is our mirror. So the radius of curvature is the radius of a sphere. This radius, you look here. So we call this one radius R. We call this one radius of curvature. So it is a line from the center of what curvature to the pole, or at any point of the mirror. So that is what we call radius of curvature. So it is a radius of a sphere of which a mirror forms a shape. It is a radius of a sphere of which a mirror forms a part. What about the principal focus? Principal focus is a point of axis of a mirror which parallel rays of light converge, or which they appear to diverge after reflection. So for concave mirrors, for concave mirrors, principal focus is a point where all the reflected rays meet or pass through after reflections. So assuming this one is our curved mirror, so these are the incident rays. So these incident rays will be reflected in this way, in such a way they pass through one focus. So this point where the rays meet after reflection, this is what we call principal focus. Principal focus is a point where the parallel rays of light appear to diverge after reflection. That is for concave mirrors. So for convex mirrors, if this one is the mirror, convex mirror, so this is the part which is not silvered. So this is the reflecting surface. If there are light rays moving to the surface of the mirror here, so after reflection, these are the incident rays. So after the incident on the surface of the mirror, they will be divert. They will appear to divert away from the mirror. So these one are reflected rays. These reflected rays appear to meet at one point behind the mirror. This point is what we call principal focus. Focus. Principal focus is a point of axis of a mirror where parallel rays of light appear to converge or diverge after reflection. That is what we call principal focus. This activity is to investigate how to locate principal focus of a curved mirrors. If this one is a curved mirror which is concave and all rays strike the surface of the mirror, so they will appear to be reflected at a common point here, this point here. So this point where the rays of light meet after reflection is what we call principal focus of concave mirrors. Principal focus is located in front of the mirror. So this principal focus is real. It is a real principal focus. It is real for concave mirrors. So consider incident rays parallel. These incident rays which are parallel and close to principal axis This is what we call principal axis of a curved concave mirror. The reflected rays pass through a point on principal axis after reflection by mirror. This point is called principal focus. So since this point, the point here is on the screen of the mirror. Here is the mirror. So in front of the screen here, it is this. So since this point is located in front of the mirror, on the screen or on the screen. So we call it real principal focus. It is called real principal focus. The images that are focused on the screen are called real images. Real images. They are called real images. For principal focus of convex mirrors, for a set of incident rays parallel and close to principal axis, reflected rays appear to diverge. So they appear to move away to principal axis from a fixed point on principal axis after reflection by convex mirrors. This is called principal focus for convex mirrors. So let us see it here. This point here, which we are seeing here, when the parallel incident rays are reflected, when they are reflected on the screen, on the surface of the mirror, so they appear to meet behind the mirror. So at that point where they appear to meet, this point we call it principal focus. That point is known as principal focus. But since the principal focus is behind the mirror, so it is known as partial. We call it partial or unreal principal focus. Partial principal focus or unreal. So the images that are also formed behind the mirror here are also called virtual images. They are called virtual images. So that is it. So let us come to focal length. So a focal length here, this experiment is being conducted to know what focal length is. So here you are going to determine the focal length of a curved mirrors, concave and convex mirrors. So for this experiment, we have concave mirror here, and the screen at the center of curvature. This is a center of curvature. If we are to draw a sphere, so it is put in the center of curvature. This one is placed. It is placed at the center of curvature. The screen is placed at the center of curvature. You see that? So now, what will be the distance between the curved mirror and this center of curvature? So the distance is known as radius of curvature. So for the experiment here, you are going to determine the focal length. You are going to determine the focal length of concave mirror. The distance between the fold and the screen. The distance between the fold and the screen is the radius of curvature. Radius of curvature R of a mirror, and half this distance is called focal length. Half distance of radius of curvature is known as focal length of a mirror. So this distance here between the fold, this one is the fold of the mirror, and this one is the center of the curvature. So this distance here is called radius of curvature. It is called radius of curvature, which is R, radius of curvature. So half of this distance, half of the distance here, the half of this distance is known as what? Is known as focal length. Half of this distance is known as focal length. When a set of parallel rays are incident on concave mirrors at an angle to principal axis. When a set of parallel rays, these are the set of parallel rays, when they are incident on this curved mirror at an angle, so at an angle, this is the angle, at an angle. So what will happen? So the reflected rays will meet here. So this point where reflected rays meet is known as the reflected rays here meet on focal plane. They meet on focal plane. This plane here. This is what we call focal plane. Focal plane is a plane which passes through principal focus. This is principal focus. Principal focus and is what? And is perpendicular to principal axis. This is principal axis. So you see the form angle of 90 here. So this is what we call focal plane. What is focal plane? Focal plane is a plane which passes through principal focus and it is perpendicular to principal axis, forming angle of 90 degrees. So this is what we call focal plane. So the distance between focal point, here and center of the mirror is called focal length. The distance between focal plane, the distance between focal point and center of mirror is called focal length, which is this distance between the two here is what we refer to as focal length. So now here we are coming to the relationship between the radius of curvature, which is r, and focal length of a curved mirror. So what is the relationship of the two here? So we understood before here that this is what we call radius of curvature. PC. PC is the radius of curvature. Let's write down here. PC is the radius of what? Is the same as radius of curvature, which is represented by r. And what? And Pf is represented by focal length. Pf here is the same as focal length, which is represented by f. So and fc is the same as focal length. Okay, for this we say that Pf is equal to what? Is equal to Pc. These two are equal. That means F is equal to F is equal to F. So here, this is the two are the same as what? As focal lengths are the same as focal length. So now we know that PC is what? Is R. PC is what? Is R here. So that means PC, which is the longest, is the same as addition of the two there. PF plus PC. Okay, now this one is going to give us PC, which is what? Which is R, and PF is the same as what? F. But these two are the same. That means we are going to replace them with the FF. So here we are going to have R. We are going to have R is equal to F plus F. So R, which is the radius of curvature, is the same as 2F. So 2F. So this gives us the formula For what? For radius of curvature. Radius of curvature is the same as 2 times focal length. So if you make f as a subject here, if you make f the subject here, like r is equal to 2f. So you will divide both sides by 2. By 2. These 2 cancel 2. So you are going to remain with it, with the f. You are going to remain with the f. F is going to be equal to r out of 2. So this is how we get focal length. Focal length is equal to radius of curvature divided by 2, divided by 2, or a half of radius. So that is the relationship of the two. That is the relationship of the two. R is equal to 2f, or f is equal to r divided by 2. Radius of curvature is equal to 2 times focal length, while focal length is equal to radius of curvature divided by 2. So that is the relationship of the two. Okay, we say thus focal length is half the radius of what? Of curvature. Focal length is half the radius of curvature. So the two here, the two angles, this angle here is the same as this one here, that small one. So, and this point is there, and this one here is the pole of the mirror. This one is the pole of the mirror. That is the center of the mirror, or midpoint of the mirror. So, and this one here is focal length. This one is a focal length, and this is known as principal focus. This one here is principal focus, and this one center of curvature. Center of curvature, and this one is radius of curvature. Radius of curvature. Okay, let us come to caustic curve. Caustic curve. So for a caustic curve, it is a curve that is formed by patterns of the rays that are reflected on the surface of the mirror that is having large aperture, or having large surface. So we say that for a curved mirror, incident rays, this one, the one we call, this one here is incident ray. Incident ray parallel and close to principal axis. This is principal axis. So incident ray, like this ray, which is what? Parallel with this line, and also they are close to one another. So this ray is known as paraxial ray. Paraxial rays. These rays that are parallel with the principal axis and close are known as paraxial rays. They converge at principal focus here. These rays here, they pass through principal focus. However, the incident rays parallel and not close to principal axis, are called marginal rays. Like this ray here is not close, there is a great distance, but it is parallel with what? With the principal axis. So this kind of rays are known as marginal rays. They are brought to focus at a different point, like here at point Q, at this point here. So these rays are brought into focus at different point here, like at point Q here, but they do not pass through principal focus. So the incident rays between paraxial and marginal rays will come to focus between Q between the two here, between Q and F, as shown here. The reflected marginal rays meet along the points of a curve, long point of curves called caustic curve, rather than at one focus or at one point. This usually happens when the mirror has a wider aperture than its radius of curvature. So it usually happens if the mirror is having wider aperture. That means it is having a wider surface. Like if we extend this one, like if the mirror is of this form, to have the large surface or large curve here. So what will happen there is that there are many reflected rays which do not pass through principal focus, but they will form a curve. This curve that is formed is called caustic curve. It is known as caustic curve. So it is known as caustic curve. It is a curve that is formed by the patterns of concentrated rays of light which are not close to the principal axis. The formation of this caustic surface can be seen on the surface of a cup, half full of tea, a cup that is half full of tea. When light from one side is reflected onto the tea by a curved surface of a cup of the cup, the reflected rays produce a curve of light, instead of a sharp spot of light on surface of the tea. So when you have tea in half of the glass, so you will observe that there will be a curve formed by the light which is reflected by tea by the curved surfaces of the glass or of that curve. So that curves formed by the reflected light, so is what we call caustic curve. Caustic curve. This effect of formation of caustic curve in a curve mirrors can be reduced by cutting off marginal rays using a narrow slide. For caustic curve not to occur, you have to reduce the mirror. You cut this part away such that the surface remain not large. So you will have this surface. So then it will reduce this caustic curve formation. The slide should allow only axial rays closer to principal axis. So this is it. You cut out the marginal rays here, leaving the axial rays, there. Thank you for watching this video. Make sure you subscribe to YouTube channel and let your friends know it also. So thank you. God bless you. God bless South Sudan education first. Bye.